So today we're going to be doing transformations, and the three we're going to be looking at are reflection, translation and stretch. We're not going to be looking at rotation today. We'll do that in a subsequent video. Just as a matter of interest, other word for translation is shift, and another word for stretch is scale, just in case people do use the other words. Okay, now there are certain rules that you just have to learn, and basically these are those rules, so I'll just quickly go through them. If there is a reflection in the y-axis, what you do is you replace x by minus x. And what we'll do anyway, later on in this video, is we'll go through some questions, so this will mean a lot more. For a reflection in the x-axis, replace y by minus y. For a translation by a right, replace x by x minus a. For a translation by b up, replace y by y minus b. For a stretch by a factor a parallel to the x-axis, i.e. that way, replace x by x over a. And for a stretch by a factor b parallel to the y-axis, replace y by y over b. Now, before we continue, there are actually a lot of confusion about stretch, so I just want to put these notes up here. So if we have y equals f of x, okay, if y is 2f of x, that means it's the same thing as y over 2 is f of x. That is a stretch by a factor 2 parallel to the y-axis. This is one B and C is that people always get mixed up. Y equals f of x over 2 is a stretch by a factor 2 parallel to the x-axis, and y equals f of 2x is a stretch by a factor half, or a compression, if you like, by 2 parallel to the x-axis. A stretch by a factor minus 1 parallel to the x-axis is the same as a reflection in the y-axis, and a stretch by factor minus 1 parallel to the y-axis is a reflection in the x-axis. It's well worth getting to grips with all of these because they really are important. So what we'll do now anyway, let's just do a couple. So this is what we're going to do now is just show, this is thanks to desmos.com, by the way. So what we are going to do is we have this line here, this brown line, which is y equals 2x plus 4, and what we're going to do is we're going to transform it into this blue line, y equals minus 3x minus 1. And a lot of people think there's only one way to do it. Well, there's not. There's an infinite number of ways to do it, and we're going to show two different methods. Okay, so the graph on the right here, this again is the same curve as this, and this blue one, it's a little bit confusing, sorry, this blue one is the one we want to get to. Okay, so what we're going to do is we need to transform y equals 2x plus 4, and we need to transform it into y equals minus 3x minus 1. Okay, so what we're going to do, so first of all, what we're going to do is we are going to reflect this in the y-axis. Okay, now the reflection in the y-axis is the black dotted line, which is that one. We just reflected it. There's the y-axis there. So we reflected the brown line in the y-axis, and the reflection in the y-axis replaces x by minus x. So that means that y equals 2x plus 4 becomes y equals 2 minus x plus 4, or equals y equals minus 2x plus 4. Okay, that's the first transformation we've done. Okay, secondly, what we're going to do is we're going to stretch it parallel to the x-axis by a factor 2. And that is this green one. That is stretching the black one, the black dotted line. We're stretching that by a factor 2 in the direction of the x-axis over there, and that becomes the green one. Well, if we stretch this by a factor 2, remember, when we do something by a factor 2 in the x-axis, we replace x by x over 2, and so therefore y equals minus 2x add 4 becomes y equals minus 2x over 2 add 4, which is minus x add 4. Okay, so we're getting there. We're still not at, remember, what we want to do is we want to get y equals minus 3x minus 1. So we've had two transformations so far, and currently we're at minus x minus 4. So number 3, what we're going to do is we're going to stretch parallel to the y-axis by a factor of 3, and that is the orange dotted line. So what we've done is we have stretched the green dotted line by a factor 3 along the y-axis, and that gives us the orange dotted line, which you will notice is parallel to the blue line that we want. And remember, this is only one way of doing it. We will do a second way, but there's an infinite number of ways. So let's just so we're at y equals minus x minus 4, and we've now stretched it by a factor of 3 parallel to the y-axis, which means that we replace y by y over 3 equals minus x minus 4, so we get y equals minus 3x minus 12. Okay, now we're almost there. So all we need to do now to get the green dotted line, the orange dotted line to the blue line, which is what we want, minus 3x minus 1, is we have to translate down by 13. And you can see if we translate the orange one down by 13, it gets to the blue one. And translating down by 13 means we have to go here, we replace y with y plus 13 equals minus 3x minus 2, i.e. y equals minus 3x add 1, which is, minus 1, my bad. Minus 3x, my apologies, that should be 3x plus 12. I do beg your pardon, that should be x plus 4, that should be x plus 4, that should be 3x plus 12, that should be 3x plus 12, and then that becomes minus 3x minus 1. Sorry about that. So we have, finally, after these 4 transformations, we have the line that we wanted, which is minus 3x minus 1. Okay? Now we can also do it another way. So let's have a look. Method 2. So method 2, we're going to start with y equals 2x add 4, just to show you there are an infinite number of ways. And remember, we want to get to y equals minus 3x minus 1. We're not going to do the graph this time. We're going to do it quicker. So first of all, let's reflect in the x-axis. Well, reflecting in the x-axis replaces y by minus y. So that becomes minus y equals 2x add 4, or y equals minus 2x minus 4. That's reflecting in the x-axis. Number 2, what we could do is we could stretch parallel to the y-axis by 3 over 2. Now, stretching parallel to the y-axis by a factor, we replace y by y over b. So stretching by 3 over 2 gives us y over 3 over 2 equals minus 2x minus 4, or y equals minus 3x minus 6. And then thirdly, we would have to translate up by 5, and that when we translate up, we replace y by y minus whatever we translated up by, and so therefore it would be y minus 5. That one would be y minus 5 equals minus 3x minus 6, i.e. y equals minus 3x minus 1. That is a second method of transforming this line here to that line there. But there's an infinite number of them. We could go on forever. We could move this one down, and we could move it up, and we could move it whatever. And if we add rotations, by the way, there are even more ways. So there's never just one way. There's always a lot of ways. So always have a look at the graph and see how you would move it to turn one thing into another. Okay. So what we're going to do now is let's do a couple of questions. And there's 2 standard questions. One is we have a curve and we are asked to apply transformations. And the other question is we are given the transformed curve and we're given the transformations, and we have to find the original transformation, the original curve. So here what we have is we have the original curve here, we have the 2 transformations here, and we're going to apply our rules. What is the transformed curve? Okay, so first of all, what we're going to do is we reflect it in the x-axis. Well, remember, reflecting in the x-axis means y becomes minus y, i.e. we have y equals x squared add 4 becomes minus y equals x squared add 4, or y equals minus x squared minus 4. That's the first thing. And then translate right by 5 units. Remember, that means that we replace x by x minus 5. So all we have to do here is replace x by x minus 5. So y equals minus x minus 5 squared minus 4. And that is our transformed curve. And if we just wanted to very quickly draw let's just draw a little chart here. It's going to be a bit rough, sorry, it's not going to be as good as Desmos. So the original one was y equals x squared plus 4, so that was that. And then what we did was we reflected it in the y-axis, which means it would go, I need a bit more space here, it would go down to here. And then what we did was we translated it right by 5, which means it would go down to here, and that would be our transformed curve is that one over there. So that's basically what we have done. So that's the answer to question number 1. Question number 2, this is quite interesting because they give us the transformed graph, y equals 4x plus 7, and they give us the transformations, and they ask us what was the original graph. Now the way that you have to do this is you have to go backwards through these, doing the exact opposite from where we finish, going backwards to where we start. Okay, so what we're going to do is that we are going to start with C, stretch 2 parallel to the x-axis. Well, the opposite of that is stretch half parallel to the x-axis. So we know that we had y equals 4x plus 7 at the end. And what we have to do is we have to do the opposite of C, and we have to go this way. We cannot go either way. We have to go this way. The order does matter. So y equals 4x plus 7, and we're going to stretch that by half. Well, stretching something by half means replace x by x over a half. So that will be y equals 4 x over a half plus 7, i.e. y equals 8x plus 7. So that's the third transformation done. The second one, translate right by 4 units. We've got to do the exact opposite by that. We've got to translate left by 4 units, i.e. we would have done to translate left, we would replace x by x plus 4. So now that would be y equals 8x plus 4 plus 7, i.e. y equals 8x add 39. So we've now done the inverse or the opposite of the second transformation, and now what we've got to do is the first transformation was reflecting the y-axis. Well, the opposite of reflecting in the y-axis is reflecting in the y-axis again, and to reflect in the y-axis all we do is we replace x by minus x, and so therefore y equals minus 8x add 39 is the original function, and that is the answer to this question here. Now, just a matter of interest, why don't we now take our original function and do these three the right way round and see if we actually get to y equals 4x plus 7. We must do, because so let's y equals minus x 8x plus 39 reflected in the y-axis. Well, that does give us, we replace x by minus x, and that gives us y equals 8x add 39, and then we've got to translate right by 4 units, and we know that that means we've got to replace x by x minus 4. So that would be that, which is 8x add 7. Okay, good, or so well, so good. And then we've got to stretch 2 parallel to the x-axis. Well, that means replacing x by x over 2. So that would be y equals 8x over 2 add 7, which is 4x add 7. So by then applying these three the right way around, we have indeed got our end transformed graph. So that's the way you do that type of question. Okay, now I hope you found this useful, but just one other thing before we finish. I should have mentioned this. Where are we here? The order that you do these transformations does matter. So you can't do them in any old order. You have to do them in a certain order. For example, if let's just take a point, I don't know, let's take this point here. Which is 10, 5, and let us imagine that we're not transforming a line here, we're just transforming a point. Now let's imagine that the first thing we did was move it up by 5. Well, if we moved it up by 5, that would get us to 10, 10, and then if we scaled by a factor of 2, that would get us in the y direction, that would get us up to 20, 10. If we did it the other way round, where first of all we scaled by a factor of 2, that would get us up to from 10, 5 up to 10, 10, and then if we added 5, that would only get us to 10, 15. So you can see that scaling by a factor of 2 vertically and then translating vertically is not the same thing as translating vertically and then scaling vertically. So you have to be careful with the order. Anyway, I hope you found this useful. We'll probably do a video on this order thing another time. Hope you found this useful. If you did, please like the video by pressing the little thumbs up button and subscribing to the Gresty Academy YouTube channel.